In our last video, we ran 5 experiments while building our deep learning model. We kept tweaking the model until we landed on a final architecture with 3 LSTM layers and 2 dense layers. Each layer had a different number of neurons, so we could achieve 99% accurate model. But how did we make that decision? I mean, why I selected that specific learning rate, the number of neurons in each layers, and so on? Well, deciding on the number of layers and neurons in a neural network is often more of an art than a science. As I know, there is no a certain way works perfect for any type of models. It always depends on what kind of problem that you are trying to solve, dataset, data types, and computational resources available. There are many ways to tweak your model and make it work better, such as trial and error, but it all comes down to how much time and computing power you've got. The basic way to find the best parameters for your model is to carefully select the parameters you want to tune, choose a range of values for each parameter, and try out all the different combinations until you find the ones that work best. This method is called grid search. It's simple and effective, and it's guaranteed to find the best training configuration for your model. However, if you have a lot of parameters, it can be impossible to test all the possibilities. If you have limited computing power, it could take forever. Since we're short on resources, we're going to try a more efficient method called Bayesian search. It's a fancy way to optimize machine learning models, and it is a great alternative to random or grid searches. It basically uses Bayes' theorem by testing and evaluating an initial random parameter value selection, and then it will tune the parameters based on the results. Think of it like using a machine to figure out the best setup for your model. Interesting, right? Now let's see how we can implement that in our real world. First, we start by opening the previous project that we worked on in the previous video. Then ensure you upload the dataset, and I will put the dataset resources in the description box. Also, don't forget to run the requirements part and the data preparation part. In this part of the project, we will write the Hypermeter tuning instructions and how we want Python to tune our model. Make sure you add all the necessary library installation instructions and import it to your project. We will use the same early stopping function, so you need to run it before starting the tuning process. Select the features and target that you want to use to train your model. It is important to watch the previous video so you will get a better idea of what I am talking about. Scaling and normalizing the data is very important for deep learning models and can make a big difference. This part of the code is responsible for preparing a data sequence for a specific time window. Think of that as taking an image of part of the goal data chart and converting it to a sequence of numbers. You can try different time windows until you find the one that works best with your model. We usually split the data into two parts, 80% for training and 20% for testing and validation. This means that the machine will not see the testing data during the training process. Here we make the model design architecture that we want to use. Actually, we ended up with this design of 3 LSTM layers and 2 dance layers based on the previous 5 experiments where we found that this is the most suitable architecture. However, you may even find a better design if you do more experiments. Also, we need to specify the parameters that we want to tune and the range of values of each one. Now, we are ready to run our hyperparameter and search for the best configuration to train our model. It is much better to buy some credits to get Colap Pro subscription so you can use cloud GPUs to speed up the process. We set up our tuner to test 50 different configurations, which took 9 hours to complete using Google Colap GPUs. If you have a machine with powerful resources and multiple GPUs, you could achieve similar results and potentially find even better configurations by allowing more attempts. So by only 50 attempts, we could achieve great results. That is why the Bayesian search method, in some cases, is much better than other methods. Don't forget to watch the previous video where we explained this project in detail. We hope this video is useful for you and you will find all the information you need to implement what is discussed in the video in the description. Also, don't forget to show your support for my channel by giving it a thumbs up and subscribing. See you in the next video.